Hello, this is Dr. Amudapriya, Associate Professor Triple E of Roshni College of Engineering and Technology, Palkulam. We are discussing about the transmission and distribution course for the regulation 2021, and here we are discussing about the fifth unit, which covers the EHVAC, HVDC, and FACS controller. First, let us see individually about AC transmission, DC transmission, their disadvantages, and what is the need for EHVAC, HVDC, and FACS controllers. And detailedly we can explain about that. First, AC transmission, while you are considering it, normally all our electric system in India is AC transmission. Advantages: the power can be generated at a high voltages, it can be stepped up or stepped down depending upon the our conditions, and we can have safe potentials for distribution. The maintenance is easy and cheaper. While considering disadvantages, it requires more copper than a high voltage one, or when compared to DC transmission line. Construction is complicated, there is skin effect, and it has capacitance, inductance, due to which charging and discharging may take place. While considering DC transmission, it requires only two conductors when compared to AC transmission. There is no inductance, capacitance, phase displacement, and surge problems. Due to the absence of inductance, the voltage drop is less when compared to that of AC for the same load and sending in voltage. So DC transmission has a better voltage regulation. There is no skin effect. For the same working voltage, the potential stress on the insulation is high. Therefore, it requires less insulation. It has less corona loss and reduced interference with communication circuits. So, HVDC transmission is free from the dielectric losses, particularly in the case of a cable. There are no stability problems and synchronizing difficulties. But the disadvantages are that the electric power cannot be generated at a high DC voltage due to commutation problems, and the DC voltage cannot be stepped up for transmission of power at a high voltage. The DC switches and circuit breakers have their own limitations. So, let us consider for the high voltage transmission. It reduces the volume of conductor material, increases the transmission efficiency, and decreases the percentage voltage drop. But the limitation is the cost. It will be a costly one. While considering EHVAC, the first one is a 375 kV system which was commissioned in Canada 1965. Voltage levels up to 365 kV have been introduced in Russia, with USA, South Africa, Brazil, Venezuela, and South Korea. But while considering HVDC, the first HVDC system for plus or minus 500 volt kV and above was the Cabora Bassa project, which was commissioned in 1979. Different types of HVDC systems are there. This is a monopolar link. Monopolar link is having one conductor and uses either ground or a C for return. The metallic return can also be used here. Next is the bipolar link. The bipolar link has two conductors. One is a positive and the other one is negative, and each terminal has two sets of converters of equal rating in series with the DC side. The junction between the two sets of the converters is grounded at one end or both the ends by the use of short electrode lines. We can see this from the diagram itself. While considering homopolar link, two conductors have the same polarity, and this can be operated with the ground or metallic return. Bipolar links are mostly used, and a homopolar link has advantage of reduced insulation cost, but the earth return overweighs the advantage. While considering FACS, it is defined as an alternating current transmission system incorporating power electronic based and other static controllers in order to enhance the controllability and increase the power transfer capability. FACS controller is defined as a power electronic based system and the other static equipment that provide control of one or more AC transmission system parameters. We can see the different types are shunt connectors, series connectors, combined series, and combined shunt series. Depending on the power electronic devices used in the controller, the FACS controllers can be classified as variable impedance type and voltage source converter. The variable impedance type controller are nothing but the static VA or SVC, normally we call thyristor controlled series capacitor or compensator, thyristor controlled phase shifting transformer, or static PST combined, which is combining the shunt and series. Normally the VSC based fax controllers are nothing but the static synchronous compensator, STATCOM. Synchronous series compensator, interline power flow controller, unified power flow controller, etc. Special purpose fax controllers are nothing but thyristor control, braking resistor, thyristor control voltage limiter, thyristor controlled voltage regulator, interface power controller, NGH, SSR, damping, etc. Main advantage is that, main advantage of VSC over variable impedance type is that STATCOM is much more compact, will have comfortability. It can supply required reactive current even at low values of the voltages. It can be designed to have been built as a short-term overload capability, and STATCOM can supply active power even if it has an energy source or large energy storage at its DC terminals. But the main drawback is that the requirement of self-commutating power semiconductor devices, the GTO, thyristors, IGBT, IGCT, is very necessary, and they themselves have their own limitations. So this is the main drawback for VSC based controllers, because they are totally dependent upon the power electronic devices. Thank you.